Oh, you have? Oh, really? Okay. Thank you. All right. How about, let's kick this up then, since we're doing this without algebra. I'll give you this question, 17. Okay? What if they gave us sine 2 theta is what? Square root of 3 over 2. Let's hope we didn't make a mistake. Okay, sine 2 theta, square root of 3 over 2. We're going to have to solve for what? Solve for theta. Yeah, it is a double angle. That's a good observation. It is a double angle, that's true. But we're going to have to solve this for what? For theta. So what do you, I know you said I see a double angle. Okay, you're right. That's a double angle. We still have to solve for what? For the single angle, theta. So let me show you guys what you would do. Okay? What I'm going to say, let me put this in red. What do we say here? I want you guys to solve this equation, okay, for 2 theta. So we're going to solve actually for 2 theta. Let me write it down. Solve for 2 theta before you solve for what? Theta. Now this is what this means here. Okay, let's determine now our quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. You can actually think of this, remember, sine here is positive, so you can think of finding again the reference angle. So we need the reference angle for actually 2 theta, not what? Theta. And where is sine positive again? If we say all students take calculus, where is sine actually equal to, the square root of 3 over 2, or I should say sine 2 theta? What quadrants is sine positive again? 1 and 2. Good job. So I'm going to get an angle in quadrant 1. I'm going to get an angle in quadrant what? Quadrant 2. You okay with that? And they should look similar in some ways. But anyway, it's not to scale. So I need here reference. I need here what? Reference. Is that true? So let me set the table here in the same way we did before. We need a reference angle. And we need a what? Reference angle. But we actually need a reference angle for really 2 theta here. And we're going to see how this changes. Okay, let's see the effect. So here's my right triangle. I have 2 theta here. And what I know is that sine of 2 theta is the square root of 3 over 2. Is that right? Sine 2 theta is square root of 3 over 2. What's the definition of sine? Opposite over hypotenuse. So this is square root of 3, and this is 2. What's the adjacent side? 1. Okay, now, what does this mean here? I'll write that down. What does this mean? 2 theta has to be what? Let me see. I don't exactly know. I'm going to have to... Okay, that seems like it's coming from... It's a special triangle here. 1, 2. What's the angle? What's 2 theta have to be again? 60 degrees? Isn't this 60, 60, 60? What's 60? pi over what? 3? Isn't that a 60-degree angle? Is that true? So what this says is my reference angle is pi over 3. So this is my reference, 60 degrees. That's the reference angle. Now, here's what I want to say to you guys. I want you to go straight to the general what? Solution. Go straight to the general solution. And I'll show you why. Okay, so let's consider this, right? We know that this angle here, now I don't know what to call this angle because we solved for 2 theta. So I can say to you, first of all, this angle here is pi over 3. And what is this angle in quadrant 2 going to be? You see this angle here, right? Quadrant 2 angle. How do we get the quadrant 2 angle here? Let's do the work right here. Isn't this going to be what? Pi minus pi over 3 for a quadrant 2 angle, this one here? Is that true? So what do you get then? You say, oh, that's 3 pi. Let's do the arithmetic. You might say, okay, that's 3 pi over 3 minus pi over 3. Okay? And 3 pi over 3 minus pi over 3, what does that give you? 2 pi over 3. So this first quadrant 1 solution is pi over 3, and the quadrant 2 solution is 2 pi over 3. Is that true? You guys with me on that? Now you might say, why are you pointing it out this way? Well, let's take a look. We want to write the general solution. Your general solution will look like this. It is 2 theta is pi over 3. It is also what? 2 theta is, what do we get through finding? 2 pi over 3. So far, so good? Let's double check. My first angle here is pi over 3. What am I going to add for the general solution? Am I going to add n pi or am I going to add 2n pi? Good job. You might say, why 2n pi? Because we don't have that situation where these angles are what? Supplemental maybe, or they're opposite. They don't differ by pi 180. We don't have that. Good. That's important. So this is my first general solution. So far, so good? How do I get the second general solution? Repeat the process. You take that angle, right? We say 2 theta is 2 pi over 3 now. And now let's go back. Do we add here a multiple of n pi or 2 pi? Do you have a solution that's in the opposite quadrant? Say no. Then what do you say? Add a multiple of what? 2n pi. So far, so good? What do you guys think? Is that pretty cool? Is that okay? That's how you get general solutions. But if you notice that we actually solve not for theta, we solve for 2 theta. We have to solve for what? Theta. Does anybody know how we solve for theta? What do we do now? What do you guys think? What should we do? Well, we do a couple of things. We're going to have to divide both sides by what? By 2. Is that right? So there's a little bit more algebra to do for the general solution. So I'll take this first one here. And isn't it true that the 2 cancels and you get what? Theta being pi over 3 divided by 2 plus 2n pi divided by 2. Do you guys know what it means to take a fraction like pi over 3 and divide it by 2? I mean, you may say, I know 2's cancel here, and I get an n pi. You're right, but this means pi over 3 now times what? 1/2 plus n pi. So my theta here is going to give us pi over 6 plus what? N pi. That's the first general solution. That comes from this equation here, okay? That comes from this right here. The second equation, we do the same thing. Notice again, your 2's are going to cancel. Is that right? And then you get theta equal to. What happens now? You have 2 pi over 3 divided by 2 plus that 2n pi divided by what? Divided by 2. So do your arithmetic. Theta is 2 pi over 3 divided by 2 plus n pi, and then theta here is going to be 2 pi over 3 times my what? 1/2 plus n pi. So what solution do we get now here? I think you just get pi over 3, right? Plus what? N pi. So here's the second general solution found by solving the second equation here for what? What do we solve for? We solve for theta. So this is what you'd have to do if you have double an angle. Okay, you guys okay with that? Anybody have any questions on this part? Nope, you sure? What about how about I say this now? What about these sequences? How do I get sequences? Let's get the sequences. So we'll have theta here being pi over 6 plus what? N pi. Multiply both top and bottom by 6. So we get pi plus 6n pi over 6. Factor pi over 6, 1 plus 6n, or 6n plus 1 times a multiple of what? Pi over 6. Don't forget, n is an integer. Let's do the other one. Let's see if we can fit the other one over here. What's the other one here? The second solution is found by taking what? Pi over 3 and adding it with 3n pi over 3. Pi plus 3n pi. Everything over 3. Pi over 3, 1 plus 3n. So I'll take 3n plus 1, pi over 3. So this is how we find the particular sequences for these solutions. Okay? So far, so good? So here's my question to you guys now. What is theta over the interval from 0 to what? 2 pi. In other words, what are my solutions here to this original equation they gave us? Sine 2 theta is the square root of 3 over 2. How do we generate these particular solutions? So we're kind of working backwards. Right? I got my sequence formula. So let's kind of look at the values of theta here. Okay, from 0 to what? 2 pi. Okay, because they might just ask that, hey, where are these values? And the way you do this is simply to, in all honesty, the way I kind of do that is I'll go straight to the general solution and see what that is, and then generate these particular solutions, and I can find very easily where sine 2 theta is actually the square root of 3 over 2. I mean, they could change this question to 3 theta, 4 theta, 5 theta, 10 theta, 20 theta. It doesn't matter. Process is the same. So remember, n is an integer. Is that right? In other words, it's these numbers. So finding these particular solutions in this case here where your angle's not theta but 2 theta or anything else, it might be that we have to do a little more work. And that's why we're doing this. So let's take the first one and say, what happens when n is 0 here? Right? We're going to take this first general solution. When n is 0, what is theta? Well, 6 times 0 is 0. 0 plus 1 is 1. Solution is pi over 6. That's in my interval from 0 to 2 pi. Is that right? Let's try n is 1 now. If n is 1, what is theta? Well, now replace what? N with 1. 6 times 1 is 6 plus 1. What do we get? 7 pi over 6. Is that less than 2 pi? It is. Is it positive? It is. Let's take now n is 2. What's theta? Replace n now with what number? 2. What's 6 times 2? 12 plus 1 is 13 pi over what? 6. Is that less than my 2 pi? No. In other words, 12 pi over 6 is exactly what the answer. So I don't have to include here this in my list. Okay, you okay with that? So we don't have to have that. Let's remove it. Does anybody want to tell me why I'm not going to choose n being negative 1, even though I can? It's a solution. If I say n is negative 1, I could plug in negative 1. It's an integer. I get 6 times negative 1 is negative 6 plus 5 is, it's going to be negative 5 pi over 6. Okay? That's a solution, just like when n was 2 was a solution. But why do I not include this one as well? Yes, you go back to your what? Restricted domain here. So if they want the solution in the restricted domain, this is how you approach it. Okay? Now that's just for this first case. You do the same thing now, not just for, oops, let's go back. N is 1 here. I erased the wrong thing. I'm going to erase this. I don't need this, even though it's a solution. It's not in my restricted domain. Let's go to the second equation. Theta is now, let's say n here is 0 again, right? And I could write it down here. If n is 0, what is theta? Well, plug in now 0 here. 3 times 0 is 0, plus 1 is 1. Oh, it's what? Pi over 3. Go to the next solution. N is 1. What happens when n is 1 now? 3 times 1 is 3, plus 1 is, well, that's 4 pi over 3. Is that less than 2 pi? I think so. N is 2. Plug now 2 here. 3 times 2 is 6. 6 plus 1 is 7. I get theta being 7 pi over 3. Is that in my restricted domain? No. So, in other words, this n being 2 doesn't give me an additional solution that's in the restricted domain. It is a solution, but it's not in the restricted domain. So we're going to have to get rid of that one. Doesn't help us in this case. So if you look in back of the book sometimes and you say, hey, why did they give me this list as solutions? Pi over 6, 7 pi over 6, pi over 3, 4 pi over 3. Why do they give me this solution set in back of the book? Well, the reason is because they all solve, I should say satisfy, the equation sine 2 theta is the square root of 3 over 2. Okay? So doubling the angle requires you to do a little bit more work. What do you guys think about that one? Is that okay? Anybody have any questions on this that we just did? So, as you guys can see, yeah, there's some work here to do. Okay? Let me give you guys a note, briefly, or another example. 19. What if they said sine not 2 theta, sine theta over 3 is the square root of 3 over what? 2 now. Let me make that very clear. And I'll say this to you guys. What does this mean? Here's what this means. Go to, again, the what? General what? Solution. For what equation? Well, go to the general solution for theta over 3. So you already knew, and I'll emphasize this, from the past example, right? The one we just did. Theta over 3 was equal to what? From the past logic we did. Go back here. You know what you're going to do? Where is it at? Go back way over here. This is what I'm saying. You're going to replace now, since you did all this work, let's erase this. Theta over 3 now. You okay with that? It's not 2 theta anymore. It's not 2 theta. It's theta over 3. So you have to find the reference for theta over 3. So I'll say solve not for 2 theta anymore. Solve really for theta over 3. And I'm going to replace now this portion here. It's not 2 theta. Oh, let's go up. Well, it's not 2 theta. It'll be what?
Theta over 3.
Thank you. And let's write it all down. We've got to go theta over 3. Let's find the work we did. Theta over 3 is what? Where is this? What am I looking for? I'm looking for this right here. Okay? I'm looking for this here and this here. So if I kind of work backwards, I get rid of this. I get rid of that. This is now theta over what? 3. I can get rid of the 2. I get rid of this. Get rid of this. Theta over now 3. Okay, let's get rid of this here. And can I get rid of some, well, I'll just keep that here. Theta over 3 is pi over 3 plus 2m pi. And way down here, I'll say theta over 3. What was the other one? Was it 2 pi over 3 plus what? 2n pi. Now, how do I solve for theta now? You're now going to multiply both sides by what? By 3. Is that true? So now my 3's cancel. Let's do the algebra. Theta becomes 3 pi over 3 plus 6n pi. Or simply, theta is what? Pi plus what? 6n pi. Double check my arithmetic. Threes cancel. Distribute. 2 pi times 3 over 3 plus 6n pi. Threes cancel. And what do you end up here? 2 pi plus what? 6n pi. Your general solutions. Okay, now you said, well, what about the sequences? Well, do some more algebra. What do you factor out? What factors out of this equation? That's pi 1 plus 6n. Is that true? N's an integer. What about this one? 2 pi 1 plus what? 3n. So for my sequences, the first one gives me, I have the equation 6n plus 1 times pi, and the second one is simply going to be 3n plus 1 times what? Times 2 pi. Go through the same process if you want to generate now the particular solutions, or let's just say the solutions that are in a restricted domain from 0 to what? 2 pi. You're going to use the sequence formula. N is 0 for the first one. What's the angle? Pi. What happens when n is 1 now? Plug in n is 1. What's 6 plus 1? Is that 7? So theta will be what? 7 pi. Is that outside of our domain for theta? Say yes, because we're looking for angles that are between 0 and 2 pi. So we have to get rid of this. Do the same thing for the next equation. N is 0. Theta becomes now 2 pi. Is that true? Double check. Is that right? Did we do the right algebra? Looks okay to me. Is that right? So what do you think this means now? What do I do? Do I keep this solution or do I throw it out? Good. Why do you say throw this out? Because it's not included in our restricted domain. The angle 2 pi for theta is not included. You say why? Because this here is a strict inequality. This means do not what? Include the 2 pi. So if you're looking back at the book, what do you think you're going to see as the only solution? Particular solution here. Theta is what? Theta is pi. And that's your solution in the restricted domain from 0 to 2 pi, not including 2 pi. Now, you're not going to look at the other solutions when n is negative, right? -1, -2, because that takes you out of the what? The restricted domain. Okay. All right, so we're back looking at these multiple angle questions. Okay, so we're going to work on some of these questions using the definition here, really, or no algebra. We're kind of looking at this. All right, so let's see if we remember a little bit about what we're doing, if you guys recall. Okay, first thing we want to remember is, I guess, to say that tangent is what? Positive? Is that right? So let's go through this. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Again, what do we say? All students take calculus. So let's start to write this all out of the way. Okay? So which quadrants is tangent? Right? What tangents are they? What quadrants should we say? Looks like quadrant 1 and quadrant what? 3. So we're going to have this situation here. Okay, now let's remember that this angle is really 3 theta. Okay, and I want to kind of point that out. And this angle actually over here is also 3 theta, but remember, we have to consider reference angles. So, we're going to look at this quadrant 1 angle is the reference. So we're going to find a reference angle here. But to let you guys know, let's go back to our tangent definition. Okay? So we know that tangent of 3 theta is a ratio. It's 1 over 1. Okay, you guys okay with that? Now, let's go in, maybe we'll draw a bigger triangle. Let's get our right triangle here. And 90 degrees, this is really 3 theta, okay? Now, tangent's going to be, what's your definition? Opposite over adjacent, and then what's the hypotenuse? Square root of 2, so you want to recognize this special triangle. Now we're considering the reference angle here. So, what can we say about this situation? Do you guys know? What does this actually mean? Right? It means that our, looks like 3, what is this here? What do we say? What's the angle? 3 theta. 3 theta is going to be what? Pi over 4. Good. So I want to go back and remind you that we just found the reference angle. This is pi over 4. And this is what? Pi over 4 over here. Okay, you guys okay with that? Now, let's consider what to kind of do next with this. So notice here we got two quadrants here. And if I said to you, how do we start to describe the general solution with this? Because we can look at it two ways, right? Let's look at this general solution here first. Your general solution can be described this way. Remember, take only one of those solutions. Take that first solution for 3 theta, right? And so we already know that 3 theta is actually what? Pi over 4. Okay, so this angle over here, we know is pi over 4. So how do we get the other angle in quadrant 3 here? Remember, we know that these angles are what in relation to another? They're opposite, right? They differ by 180 or pi. So we can just simply describe the first solution as pi over 4, and then we can get the other solution by adding a what? A pi value. Is that right? We can add this rotation of pi. But in general, we really add a multiple. So that's really going to be n pi. So I can describe, generally speaking, every solution here. Quadrant 1, and add a multiple or subtract a multiple of pi. I get a coterminal angle. Okay, this is coterminal. And we're actually getting every coterminal solution. That's our general solution. So we can simply say, take that first solution for 3 theta, and it's pi over 4, and add a multiple of n pi. We're generating every solution now, just like we described the other day or yesterday here. Okay? All right, I want to go through this in detail. Now I'm going to say to you guys, for the general solution, right, we need to solve this not for, 3 theta. They want us to solve for theta. So we're solving all of these for theta. All right, how do we do that then? Well, just simply do what? Divide 3 now to both sides and perform your arithmetic. So, the 3's cancel, and here's what you end up with. Theta being pi over 4, right? Divided by that 3 plus n pi over 3. And so that your solution will be pi over 4 times 1/3 plus n pi over 3. Theta will be pi over 12 plus n pi over 3. So here's the general solution. We're just going to simply finally divide both sides by 3. And remember, n is an integer. So here's your general solution. Okay, now if we want to notate the sequence here, just do some algebra. And algebraically speaking, we get pi over 12 plus n pi over 3, right? We're going to multiply now, since we need to have the same denominator. When we add fractions, multiply the second one here, both numerator and denominator, by 4. So now your theta will be, looks like pi over 12 plus 4n pi over 12. And let's look at the algebra. Factor out your what? Pi over 12 looks like. And you get, what do you get? 1 plus 4n, double check. So we get 4n plus 1 times pi over what? 12. So let's double check our algebra. Looks like we're okay, right? So now, if we want to find solutions here, let's now let n be what? 0. What's our first solution when n is 0? Right, plug in a 0 here, we get what? Pi over 12. All right, plug in n as 1. What happens when n is 1 now? We're going to generate our solutions. Don't we get theta being, do order of operation, 4 times 1 is 4 plus 1? 5 pi over what? 12. Okay? Now, you might say to me, when do we stop? When do we stop generating our solutions? Does anybody know the answer? The answer kind of is when they tell us to. Okay? Let's see what I mean by that. What's 4 times 2? Is that 8? And 8 plus 1 is what? What's 8 plus 1? That's 9 pi over 12. So when I say to you, they'll tell us, they'll give us possibly this what? Restricted domain. Is that true? So you're going to have to tell me, what are all the solutions here in this restricted domain? Do we stop listing the solutions, or do we keep going? How do we know when to stop? Are these angles positive? Right? So notice we're not taking, well, what are the solutions here? Are these positive angles? Where do we actually stop? About 2 pi. Good job. Good job. So let's kind of continue then. And let's say n here is 3. And then theta will be, if I change this now to what? To 3, we get, what do we get? 13 pi over what? 12. Are we actually past 2 pi? What do you guys think? Is 13 12s is just a little bit more than 1? Okay. So I guess we got to do what? So if they ask us for these solutions, as you guys see, this approach here is pretty much what? In my opinion, the best approach. N is 4. 16 plus 1 is what? That's 17 pi over what? 12. Where would 2 pi be? Your numerator should be about 24. Is that right? Okay, so let's keep going. We're going to have to generate all these solutions. What if they told us this? We think it was simple because they say restrict the domain, but not always, generally speaking, so easy. So we got a 5 there, and 4 times 5 is 20. And what's 20 plus 1? So this is 21 pi over what? Over 12. Okay, are we at 24 or above? No. But you know what I suspect? When n is 6, what should happen? Would that get us over the 2 pi? Yeah. So if n is 6, we get 24 plus 1 is what? 25 pi over what? 12. So not necessary, because now we're over 2 pi. They restricted the domain. We considered this situation. Notice if they had no restriction, your general solution would be the way to go. Is that right? If there's no restriction, that's implied that this is over all real numbers. So if they don't restrict your domain, yeah, pretty good to just do what? Here or what? Here, and you're done. If they ask for solutions within a restricted domain, you're going to have to generate them. And moreover, are there any other solutions, you think? What do I mean by that? What happens, notice, this n has to again be what? An integer. And integers, in case you forgot, are these kind of numbers. Numbers are on this list. So we include even the negatives. So what would have happened if I said to you, what angle do we get when n is negative 1? We get negative 4 plus 1. Is that true? What's negative 4 plus 1? So theta will be now, looks like it's a negative 3 pi over 12. And that reduces to theta being what? Negative pi over what? 4. Is that in my restricted domain? No. So we don't need this solution either. And that's that. So let's actually, continue here, looking at some other multiple angle arguments, meaning, you have this here, multiple angles, not just theta, but 3 theta. How about if we look at, for example, let's call this one number 23, in case we use this as part of some bigger project in the future, right? So, because I wanted to show you guys a couple of other things. Maybe we should just move on at this point. We can try another one. Maybe we should go into some details about what's our time like here. Oh, we could go into those details. Maybe we should just try one more briefly. I don't know how you guys feel. If you wanted to see another sort of, let's see what we have here. Tangent is positive. Sine, okay, looks like we got some positive angles there. Okay, got a fraction. I think I understand what I want to do. Let's do this. Cosine of maybe, that's theta over 3. I see. Let's do let's do the following. How about if we have this? Let's try this out here. Let's look at cosine theta over 2, a half angle, actually being what now? Let's make it negative. How about we make this negative 1/2? Should we try negative 1/2, or what should we try? Let's try something else. Let's see what we got here. We got a well. How about if we say, I guess we'll stick with that, negative 1/2. Okay. All right, so as you guys notice, we're going to start the process. This is again what? This is negative. So we're going to have to consider our reference situation. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take calculus. Okay. Where's cosine negative? 2 and what? 4. Is that true? Quadrant 2, quadrant 4. So we need over here a what? We need our reference angle. Same angle here. We need that reference angle. So cosine is negative in these two quadrants. All right, now how do we find that reference? You guys know? You're going to take cosine of theta over 2 actually being positive 1/2. So if it's positive 1/2 now, right? Let's go to our, doesn't look like it looks funny. Let's see. Theta over 2. What's the definition of cosine? Adjacent over what? Hypotenuse. Is that right? So we got 1, we got 2. What's the opposite side going to be if this is 1, 2? Good job. Special triangle. What angle is this? What do you guys think? What angle is this? This is by the way of reference, right? By way of reference. So my reference angle really is pi over what? So pi over 3? Okay. Because this is a special triangle. So this here, this reference here, is pi over 3. This is what? Pi over 3. Okay. Now, if this is pi over 3, then let's see what our angles are going to look like. So we know then, what do we know? How do we get these angles? What is, let's go back to this. Oh, we're going to have to kind of think about it this way. If this is pi over 3, how do we obtain a quadrant 2 angle? What's a quadrant 2 angle solution going to be? What's it going to look like? Let's say theta over 2 will be what? Pi minus what? Pi over 3. Is that right? And then also, so we know that theta over 2 will be, how do I get a quadrant 4 angle? Now this was quadrant 2. How do we get quadrant 4? Pi what now? Plus what? Pi over 3. Is that true? So we're going to get these angles here. Now we're going to have to do some, arithmetic. 3 over 3, 3 over 3. So we'll get these answers here. Let's put this up like this. Theta over 2 becomes, what's this? 2 pi over 3. And what's the other angle? Theta over 2. Is that going to be what? 4 pi over 3? Double check. Is that what you got? Okay, now I want to go back and remind you guys of a couple of important ideas here. These solutions, if we're going to kind of consider all other solutions that are coterminal, we're going to start to say, okay, what about this general solution idea, right? How to describe the general solution? Well, go back to this idea. Okay, since these solutions are not in opposite quadrants, they're in quadrant 2, quadrant 3. Meaning, here's my first solution. Another solution is not what? Here. It's not there. So what do we then say with this? Take that first solution, and how do we find that first solution and all other solutions that are coterminal? Add a multiple of 2m pi. So I'm going to take that, and I'm going to add, let's put it in red like we did the other day, 2m pi. Similarly, we're going to have to do the same for the second one, because if we go now to the second solution here, right, we don't have solutions that are in opposite quadrants. We don't have a solution that's in quadrant 1. So they don't differ, or they're not in opposite quadrants by 180 or pi. So similarly, for the second solution, we add the what? The 2m pi. Okay? So this is for our general solution now. So let's write this here. And we're not really done, so I can kind of let's write it down here. Now for our general solution, because of the fact that we want theta, not half a theta, you're going to end up you're going to multiply both sides now by what? By 2, is that right? Multiply the left by 2 and the right by 2. So your 2's cancel in both cases. Let's see what happens here now. We get theta being, looks like it's 4 pi over 3 plus 4n pi, and theta being 8 pi over 3 plus 4n pi. Okay, and then if you said to me, well, what if they restricted the domain now, right? What if they said, what are the solutions in the interval from 0 to what? 2 pi here, not including 2 pi. And they might ask us that. So I'm going to give you guys every gory detail, because even, if this resource is up, not just for this class, for calculus experience, or calculus 1, calculus 2 experience, calculus 3 experience, you can refer to this, because these details come out in those courses. So let's actually generate the sequence here so that we can look at particular solutions. So let's see the sequence. The sequence here would be theta is 4 pi over 3, right? Yes, plus 4m pi. Multiply top and bottom by what? By 3, and do the algebra. So theta becomes 4 pi over 3 plus 12n pi over 3. Factor. Looks like we can factor out what? What comes out of these? Is that 4 pi over 3? Double check. And then 1 plus 3n. N is an integer, right? Double check that solution. The second one, we say, okay, theta being 8 pi over 3 plus 2n pi, and multiply top and bottom again by, let's go back. Yeah, by 3, sorry. Put it over here. So you get theta being 8 pi over 3 plus 6n pi over 3. And so your theta now is going to be, what can we factor out? Probably a what? A 2 pi over 3, looks like. So, yeah, GC, greatest common factor of 8 and 6, looks like it's going to be 2, right? You got 2 pi, really, over 3. Okay, so that looks like this will be 4 plus what? 3n. N is an integer. So we get 2 pi over 3, 3n now plus 4. So here's the sequence answer. So let's work with this and try to generate these solutions. Do you guys want to look at the solutions here, or do you want to move on? I mean, do you want to look at these particular solutions? Could you generate this on your own, you think, or not? Right, what would you consider here? N is 0. Is that right? What's theta if n is 0? Is that 4 pi over 3? Okay. What happens when n is 1? Do we get theta being what? Is that, double check my arithmetic, 16 pi over 3? Replace a 1 there. 1 plus 3 is 4, right? 4 times 4 is 16. Uh-oh, you're already out of what? You're already out of the range, aren't you? You okay? You're out there. Yeah, question.
For theta, wasn't it supposed to be 8 pi over 3 plus 4n pi instead of 2n pi?
Oh, thank you so much. Oh, yes. Thank you. You just saved us. You just saved us some heartache. Where are we at? Sequence. We're doing this sequence. We're okay here. We're just not okay where? Here. Is that true? That's your remark, right? Okay, good job. Thank you. Is that correct? You guys okay with that? So that's going to change 6 to what? To 12. And then that's going to change this here too. So GCF is going to be 4, it looks like. Is that right? This will be 4 pi over 3. And then what do we have now here? Looks like we'll have 4 times 3 is 12. Yeah, so we have what now? 2, is that right? 2 plus what? 3n, is that right? Or 3n plus what now? 2. Double check, are we okay? Are we okay with that now? Okay, let's go back to the point, though, of generating solutions. Okay, I get to fill this one out. Is that true? Why do I fill this one out? Is that greater than 2 pi? Remember, what's the idea? What if they restrict the what? The domain here. So I want to say to you guys that this solution for theta gets thrown out. We don't have to consider anything larger. Is that right? And in fact, if n is -1, you get a negative angle. So we're pretty much done here throwing this one out because it's outside of the restricted domain. Now let's go through and try some of these here. What if n here was 0 again? Now what is theta going to be? Anybody know? If n is 0 for the next one. What does that give you? Don't we also get what? Do you get 4 pi over 3 again? Double check. Is that right? Is that true? Okay. So we already know that's a solution. What if n here is 1? What do we get now? What is theta? 2 pi over 3 times, when n is 1, what do we get? What is this? Is that 5? So this gives us what? 10 pi over 3. Okay. Now, let's go back here. What happened to our 8 pi over 3 solution? Anybody know what happened to the 8 pi over 3? It might be over here. This is n is 0. We get 4 pi over 3. N is 1. We get what? Unless we made a mistake in our arithmetic here. So let's go back. Where is the 8 pi over 3 here? We're here. Right? We already know that theta should be 4 pi over 3, and theta should also be what? 8 pi over 3. Is that right? Okay. So we're going to look for solutions here. Now let's double check, see if our algebra. 4 pi over 3, that's 12 pi. Okay, over 3. So we're okay here. 1 plus what? 3n. So we're okay right here. Looks like we're good. Is that true? Everybody with me on this one? Now, if we take the 8 pi over 3 plus 4n pi, so 8 times 4 is what? That's 12 pi. So we get 8 pi over 3 plus 12n pi. 4 pi over 3 comes out. That's 2 plus 3n. Okay. Well, let's see. Does anybody see what's going on here with this here? Looks like we factored this out. Oh, we're right here. This is where this issue is. Yeah, there it is. Okay, good job. Okay, let's try that again. There it is. Apologize for you guys. Knew something was wrong. There's some inconsistency here. All right, there we go. I found it on my own, so You guys don't get Flamin' Hots, right? Extra credit. What happens when n here is 0? Right, what's your theta? N is 0. Well, there you go. There's the 8 pi over 3. Oh, I'm glad I'm not losing my mind. Now, n is 1, and what happens here when n is 1? 5. 5 times 4, that's 20 pi over 3. What do we do with that solution? We throw this out. Anybody know why we throw it out? Because the restricted domain is what? 0 to 2 pi. So here's your two solutions, like we thought it would be. 4 pi over 3 and the 8 pi over 3. Okay, let's emphasize that. Anyway, good job. Thank you so much. Now, let's go on and move on to these other kind of questions that you're going to use your calculator for. So remember, we've got to make a really comprehensive study of finding these angles and going through the process. I'll call that 25, and one day I'll make a worksheet, and then people have to do 50 of these maybe.